This is a tutorial on distinguishing good versus bad data graph. Upon finishing the test, the device will wait for you to either accept or reject the data you have just collected. Please follow this tutorial and the guessing practice at the end of it to make the right and quick decision. So what does a good graph look like? The first thing you can look at is the axis ranges. The typical range for the angle, which is in radians, is 0 to 1. The typical range for load, which is the vertical one here, is 0 to 100. Some very small negative numbers can also be accepted, like the -1 or -5. A good graph usually contains 4 essential sections. The first one is the straight section. On the graph, the data line should begin with a straight rising segment. What it feels like at test or corresponding to is that the torque resistance increases when we push the handle forward. As you can see from the graph, this good graph actually begins with a pretty straight line at first. The second section is the intermediate section. On the graph, the data line should rise slowly or goes up and down for this section. What it feels like at test is that the torque begins to break. The next one is the failure section. On the graph, the data line should drop drastically in this section, and you should feel at test that the torque fails and the resistant force suddenly disappears. The last one is the post-failure section. In the graph, the data line goes up and down or tumbles in this section. What happens is that the operator pulls back the device before pressing the stop button, or he or she just reaching for the buttons right after the test when the device is still recording data. This section can be minimized by following the suggestions on good data collection, which will be introduced in another video. Please note that the length of the intermediate section can vary a lot according to the different plant types and their moisture. This is a good example of a graph with very short intermediate section. Here we have more examples of good graph from the previous test. As you can see, they all start with a pretty straight section and then follows the intermediate section. As you can see, the length of the section and the direction varies a lot. The one in the top left actually has a pretty long intermediate section. The one down there in the down right has a pretty short intermediate section. They are good. And then follows the failure section, which all look pretty similar. And the last one is the post-failure section. As you can see, the two major components which we should identify during the test is the straight section and the failure section. So what does a bad graph look like? There are so many things about the bad graph. The most things in common is that the lurch. What happens is that the operator shifts body weight during test by taking a step to keep balance when he or she just trying to push the handle forward, or the device or stork hits other plants during the testing, so the load cell or the force sensor actually sends some unusual load. Here's another example of the lurch. This is another issue of the bad graph, the random noises. As you can see from the graph, it's just some scattered data, which is meaningless to our purpose. Here we have some practice for you, which will guess the following pictures, whether they are good or bad. If you feel confident enough, you can just exit and proceed to the further videos. This guy, is it good or bad? It's a bad one because it has lurch here and the scale for the angle axis is not right. What about this guy? Good or bad? It's a good one. What about this one? Is it good or bad? It's a bad one because it lacks the straight section and the scale for the angle axis is not right. What about this one? Well, this one is pretty easy. It's bad because it lacks all the 4 sections and scale for the angle axis is not right. What about this one? Well, this one has a pretty long post-failure section, but it is still okay. What about this guy? Good or bad? It's actually bad because it lacks all the 4 sections and the scale for angle axis is not right. What about this guy? It's actually good, and it's also a good example of a graph with pretty short intermediate section and pretty long post-failure section. What about this guy? Good or bad? It's actually good. What about this one? Well, it looks pretty different from the previous graph, but it's actually a graph from the lab test, which is bad because the stock never failed in this case. As you can see from the graph, as we retract the handle, and we can still read some load sensor data from the graph, which means that the stock never failed in this case. What about this guy? Good or bad? This one is good. What about this guy? Well, it's pretty easy. It's bad because it's just random data and both the angle and load axis scale are wrong. What about this one? Well, it's bad for the same reason. Random data, both angle axis scale are wrong. What about this one? It's a bad one. What about this guy? It's a good one. What about this one? It's a bad one because of the lurch. What about this one? Good or bad? It's a good one. What about this guy? Good or bad? It's a bad one because of the huge lurch here. It must have hit something during the test. What about this one? Good or bad? It's actually a bad one because of the lurch at the very end of the intermediate section. What about this one? It's a good one. What about this one? Is it good or bad? It is actually a pretty clean and good example of the good graph.